funky.
Hi everyone, I'm teacher Yana, and welcome to another lesson in physical science. In this video, we will find out more about circuit connections. Are you excited? To give you a heads up, we will first encounter with a brief background check on circuits. Next, different types of circuit connection with their uses and application. So that's it, let the learning begin. First electric circuit was invented by Alessandro Volta in 1800s. He discovered he could produce a steady flow of electricity using balls of salt solution connected by metal strips. Later, he used alternating discs of copper, zinc, and cardboard that had been soaked in a salt solution to create his voltaic pile. By attaching a wire running from the bottom to the top, he caused an electric current to flow through his circuit. The first practical use of the circuit was in electrolysis, which led to the discovery of several new chemical elements. Isn't it surprising how circuit connection works? Like it helps us a lot with a lot of things. Like for example, watching a TV like Mr. Bean did. Using computers to do your master requirements like Mommy Pig.
It's my old computer.
Or using kitchen appliances to prepare food. Or surely you can relate to this, using your cell phones or tablets to post a picture or a selfie. You might have been wondering how charges can continuously flow in a uniform direction through wires without the benefit of these hypothetical sources and destinations. In order for the source and destination scheme to work, both would have an infinite capacity for charges in order to sustain a continuous flow. This is where circuit connections would come in. So what is an electric circuit? An electric circuit is a system of conducting elements designed to control the path of electric current for a particular purpose. Circuits consist of sources of electric energy like generators and batteries. Elements that transform, dissipate, or store this energy, such as your resistors, capacitors, and inductors, and of course your connecting wires. Circuits often include a fuse or circuit breaker to prevent a power overload. So this is a basic set of symbols that you may find on circuit diagrams. First, you have your open switch, the battery, lamp or bulb, close switch, the cell, the ammeter, the buzzer, the fuse, resistors, and your voltmeter. It is very important to know the basic parts of a simple circuit and the symbols that relate to them. A simple circuit has conductors, a switch, a load, and a power source. Here are the functions of each part. Conductors. These are usually copper wires with no insulation. They make the path through which the electricity flows. One piece of the wire connects the current from the power source to the load. The other piece connects the load back to the power source. Next is switch. The switch is simply a small gap in the conductor where you can close or open the circuit. When the switch is closed, the circuit is closed and electricity flows. The load. The load is a small light bulb or buzzer that lights when the circuit is turned on. The load is also known as the resistor. Lastly, you have the cell. The cell is the power source. Note that more than one cell put together is known as the battery. The diagram shows how a basic circuit looks like. Series circuit. A series connection is a circuit in which resistors or loads are connected end-to-end so that the circuit will have only one path through which electric current flows. In series connections, the same current flows across all the branches of the circuits, but different voltage across it, thus making the resistors to have different voltage across them. Each resistor or load will experience a voltage drop. The applied voltage is equal to the sum of the voltage drop across the different parts of the circuit. Voltage drop is proportional to the resistance current being the same throughout the circuit. When loads are connected in series, the loads will tend to have a common switch. This kind of connection is employed in school halls or street lights. Advantages of series connection. Series circuit don't get overhead easily due to the high resistance when more load added in the circuit. The lifespan of battery in series circuit is more as compared to parallel. It is most simple method of electrical wiring and fault can be easily detected and repaired as compared to parallel or series parallel wiring.
Connected along a single path with the current flowing in the same direction through each component. For instance, if the source current in a series circuit is 5 amps, then no matter where along the circuit you take an ammeter reading, it will also register 5 amps. Although current is constant throughout a series circuit, voltage is not. Voltage in a series circuit is divided across the load resistors so that the sum of the individual voltages equals the total voltage applied. This relationship is known as Kirchhoff's law. By adding the voltage drop across resistors 1, 2, and 3, you can determine the total voltage applied at the source. In this case, the total voltage is 5 volts plus 4 volts plus 3 volts or 12 volts total voltage.
The series connection is so named because the resistance are connected end to end and all the charge flowing in the circuit must go through each resistance in sequence. The same current thus exists in each resistance because there are no alternative paths and charge which cannot be stored in the wires. Since the current goes through each resistor in the circuit, the total resistance is the sum of the individual resistances. That is, R series equals R1 plus R2 plus R3 plus so on and so forth, where R series is the total resistance of a series connection of resistors. For example, suppose the battery has a voltage of 6.0 volts and the resistances are 6.0, 4.0, and 2.0 ohms. Letter A. Calculate the total resistance of these resistances in series. Letter B. Calculate the current flowing in the circuit. Letter C. Find the voltage drop across each resistance and the total voltage drop of the three resistances together. Solution letter A. The total resistance is simply the sum of the individual resistances as given by the equation. Solution letter B. The three resistances together can be considered equivalent to a single resistance of 12.0. The current is then given by Ohm's law. Solution letter C. Solving Ohm's law for voltage yields V equals IR. This is interpreted as the voltage drop in that resistor. Thus, the three voltage drops are Now, the total voltage drop is the sum of the individual voltage drops. Note that this is exactly equal to the voltage supplied by the source. Parallel circuit. Resistors, loads, are said to be connected in parallel when the end of each of the resistors or loads have a common point or junction and the other ends are also connected to a common point or junction. Such circuits are known as parallel circuit. Unlike the series circuit connection, when finding the total resistance in a parallel circuit, the reciprocal of the individual resistance is taken. Thus, when a number of resistances are connected in parallel, the reciprocal of the effective resistance is given by the arithmetic or algebraic sum of the reciprocal of the individual resistances. Parallel circuit connection have the same voltage flowing across all the branches of the circuits. Different resistors have their individual current. Advantages of parallel connection. It is possible to add more light fixture and load points in parallel circuits according to the future need as far as the circuit is not overloaded. Adding additional devices and components won't increase the resistance but will decrease the overall resistance of the circuit, especially when high current rating devices are used such as air conditioner and electric heaters. Parallel wiring is more reliable, safe, and simple to use.
The second basic circuit form is known as the parallel circuit. Like a series circuit, the parallel circuit has multiple components or loads. However, in a parallel circuit, the current has multiple paths along which to travel. Each of these paths is known as a branch. An important difference between a series and a parallel circuit is that the voltage in the parallel circuit is the same across all branches. The current along each branch will vary, but when added together, these various branch currents will equal the current at the source. For example, look at these ammeter readings at the various branches and junctions of a parallel circuit with a source current of 10 amps. As the 10 amp current travels away from the source, it splits at junction 1 into two branches that have currents of 2 amps and 8 amps. The circuit branches again at junction 2, and the 8 amp current splits into 3 amps and 5 amps. As the current returns through junction 3, the 3 amp and 5 amp values recombine to give an amp value of 8. At junction 4, the 2 amps and 8 amps currents recombine to equal the 10 amps of the original source current. An important difference in a parallel circuit is that voltage is the same throughout the circuit. So, using a voltmeter to measure volts at each load will yield voltage readings equal to that at the source.
For example, suppose a 1.0 kilowatts microwave oven and a 500 watts coffee maker are operated simultaneously on 120 volt electricity. Letter A. What is the current through each appliance and what is the total current? Letter B. Calculate the resistance of each appliance and the total resistance of the circuit. Solution letter A. The current can be calculated using equation P1 equals I1V. Solution letter B. We can use Ohm's law or either of the power equations involving R to find the resistances. Picking Ohm's law is I equals V over R and solving it for the R yields. Note that the full voltage is used since the resistances are connected in parallel. This cannot be done for resistances in series. Now, the total resistance can be found. As mentioned, the total resistance is less than either of the resistances in the circuit. An alternative method of finding the total resistance is to solve Ohm's law for R and use the total current found in part 4, letter I. A circuit with a combination of series and parallel connections. One example is the switch that is in series with the respective devices and the devices are in parallel with one another. Switches are variable resistances. When they are closed, the resistance is negligible, and when they are open, the resistance is essentially infinite. The open light switch on the right makes the resistance of that branch essentially infinite, since the switch and the light are in series. The current through that branch is thus zero. Similarly, the closed switches in the other branches have negligible resistance and allow current to flow as if there were only a wire and no switch in the branch. Here are some applications of the series parallel combination circuits. LED. Electronic components that emit light when a voltage is applied are often arranged in parallel and in series. One advantage of arranging LEDs in parallel is that when one LED light goes out, the rest will stay lit. In a series LED arrangement, when one light goes out, so will all the rest. Series LED arrangements, however, require less electrical current to operate than parallel arrangements. Battery voltage. Battery voltage is increased when batteries are placed in series. Placing two 5-volt batteries in series results in a battery with a voltage of 10 volts. When connecting batteries in series, the batteries need not have the same voltage, but they should have the same ampere-hour capacity. Voltage dividers. Resistors are arranged in series to divide voltages to power electronic devices that require different voltage levels. Taps, the points within the series resistor network that have different voltage levels, are then wired to other electronic components such as voltage regulators, which can be used to produce a constant voltage equal to the tap voltage.